Hello and welcome to Mr. Alvarez's virtual chemistry classroom. Today we'll be talking about calculating density using Table S. Our aim for today is how can we use Table S of the chemistry reference tables to solve density problems. But before we do any calculations, let's take a deeper look at the concept of density. Remember, the formula for density is density equals mass over volume. Mass is the amount of matter a substance contains, whereas volume is the amount of space an object takes up. So here we have 4 boxes of equal volume. They all are the same size, so it's the same amount of space. What changes in these 4 boxes, as we go from left to right, the number of particles increases. So there's more matter in the 4th box than the first box. In the first box, we have 5 particles, 1, 2, 3, 4, 5. And in the 4th box, we have 37 particles. Remember, all the same space, the same volume, but we're cramming more particles in that same space. So the more particles crammed in the same space, the higher the density is going to be. And that brings us to practice problem number 1. Problem number 1 states, a block of iron, which is element Fe, has a mass of 750.0 grams. Calculate the volume of this block of iron. So the first thing we're going to do, as always, is write the formula. D equals M over V. Density equals mass over volume. Now, when we're finding the knowns and unknown values, we have mass. We're trying to find volume, but it doesn't give us the density. But since iron is an element, element number 26, we can look at table S of the chemistry reference tables. We go down to element 26, which is iron. We find the density, which is the second to last column. So if we go across, we find the density of iron to be 7.87 grams per cubic centimeter. So remember that number, 7.87 grams per cubic centimeter. So when we go back to the problem, density, 7.87 grams per cubic centimeter. We also have the mass, which is equal to 750.0 grams. And we have the volume, which is what we're trying to find in this problem. So that is our question mark for this problem. So we could plug in 7.87 grams per cubic centimeter equals mass 750.0 grams over volume, which we don't know. The next step is we're going to have to cross multiply. So we do V times 7.87 grams per cubic centimeter, which gives us V times 7.87 grams per cubic centimeter equals 750.0 times 1. So it leaves us with 750.0 grams. Anything times 1 is just going to be the same number, so we can just get rid of the times 1. Then our last step is we're trying to find volume by itself. So we must divide both sides by the 7.87 grams per cubic centimeter. When we do that, the 7.87 grams per cubic centimeter cancels out, so we're left with V on the left side equals 750.0 grams over divided by 7.87 grams per cubic centimeter. Here, the units of grams and grams cancel out, and we're left with the unit of cubic centimeters, which is perfect because we're trying to find volume. So let's do that mathematical operation, 750.0 divided by 7.87. Write down every single number that comes out of your calculator. So 95.29860.229 cubic centimeters. Last step, we solve and we round to significant figures. So since we calculated, we just have to do significant figures. We look at our original numbers. 7.87 has 3 significant figures, where 750.0 has 4 significant figures. We go with the least amount, 3 significant figures. 1, 2, 3. Put a box around the next number, the 9. 9 is 5 and above, so we round up. This 2 becomes a 3. So our final answer, volume equals 95.3 cubic centimeters. Practice problem number 2 states, magnesium, Mg, element 12, ribbon has a volume of 86.22 cubic centimeters. How much mass does this piece of magnesium ribbon have? So here, we have the volume of the magnesium ribbon, and we're trying to find the mass. While we don't have the density, we can find that on table S. But first, let's write the formula. D equals M over V. Density equals mass over volume. Let's find the density of element number 12, magnesium. We go down to magnesium, element 12, the second to last column, and we have a value of 1.74 grams per cubic centimeter. Remember that number, 1.74 grams per cubic centimeter. So you write that down, 1.74 grams per cubic centimeter, as the density. The mass is our unknown value, and our volume is 86.22 cubic centimeters. Now we plug in 1.74 grams per cubic centimeter equals mass, our unknown, divided by our volume, 86.22 cubic centimeters. We're going to have to cross multiply, put this over the number 1. So we multiply the 1.74 grams per cubic centimeter times 86.22 cubic centimeters. So let's rewrite that, 1.74 grams per cubic centimeter times 86.22 cubic centimeters equals mass times 1. Once again, anything times 1 is just going to be that number, so we don't have to write that times 1. Before we do any multiplication, when we multiply 1.74 grams per cubic centimeter times 86.22 cubic centimeters, the cubic centimeters and cubic centimeters cancel out. So we're left with the unit of grams, which is perfect because we're trying to find mass. Now we multiply 1.74 times 86.22. Write down every single number in your calculator. So we have 150.0228 grams equals your mass. Final step, we round to the appropriate number of significant figures. Since we're multiplying, least number of significant figures. Our original numbers, density 1.74 has 3, where the volume 86.22 has 4 significant figures. So we go with the least number, 3. 1, 2, 3. Put a box around the next number. We see it's a 0, less than 5, so all these numbers cancel out. And left with 150 grams, which is your mass. Now this number only has 2 significant figures, the 1 and the 5. If you wanted to make that 0 significant, all you had to do would be put a decimal point at the end. So now this 150 grams with a decimal point at the end is 3 significant figures. Box off your final answer. And we're done. Practice problem number 3 states, tungsten, W, element 74, has the highest melting point of all metallic elements and is used to make filaments for incandescent light bulbs, fluorescent light bulbs, and television tubes. A tungsten filament in a particular light bulb has a mass of 0.640 grams. What is the volume of this tungsten filament? As always, we start off by writing the formula. D equals M over V. And then we figure out our known and unknown values. We have the mass, 0.640 grams. We're being asked for the volume, but once again, no mention of density. However, we can use table S of the chemistry reference tables to find the density of tungsten. So this time we have to go to page 11 of the chemistry reference tables. Still table S. Tungsten, element 74, second to last column, has a density of 19.3 grams per cubic centimeter. So remember that number, 19.3 grams per cubic centimeter. So density, 19.3 grams per cubic centimeter. Our mass is 0.640 grams, and our volume is our unknown quantity. Next, we plug in density, 19.3 grams per cubic centimeter, equals mass, 0.640 grams, over volume, which is our unknown. Next step, with the density, the 19.3 grams per cubic centimeter, over the number 1, and we cross multiply. So here we have 19.3 grams per cubic centimeter times V equals 0.640 grams times 1. Once again, we're multiplying by 1, so we don't have to write the 1 because anything times 1 is just itself. Here, we want to get the volume by itself, but this 19.3 grams per cubic centimeter is in the way. So we want to do the opposite mathematical operation. So the opposite of multiplication is division. So you divide both sides by the 19.3 grams per cubic centimeter. Divide by 19.3 grams per cubic centimeter. On the left side, the 19.3 grams per cubic centimeters, they cancel out. So we're left with volume equals 0.640 grams divided by 19.3 grams per cubic centimeter. The units cancel out, grams and grams cancel out. We're left with the unit of cubic centimeters, which is perfect because we're trying to find volume. And our last step is to divide 0.640 divided by 19.3. Write down every number that comes out of your calculator. I have a small number, 0.033160622 cubic centimeters. The last step, we solve for significant figures. We round to significant figures. Density 19.3, 3 significant figures. 0.640, 3 significant figures. So our least number of significant figures is 3 significant figures. Go to the first significant figure, 1, 2, 3. Put a box around the fourth number. In this case, it's a 6. 6 is 5 and above, so we round up. This one becomes a 2. So our final answer, V equals 0.0332 cubic centimeters. And we box off our final answer. And finally, we have practice problem number 4. Practice problem number 4 states, radon, Rn, is a cancer-causing radioactive gas. You cannot see, smell, or taste radon, but it may be a problem in your home. The Surgeon General has warned that radon is the second leading cause of lung cancer in the United States today. If a sample of radon gas has a volume of 12,000 cubic centimeters, what is the mass of this sample? So, once again, the formula, D equals M over V, density equals mass over volume. Here we're given the volume, 12,000 cubic centimeters, and we're trying to find the mass. So once again, we have to look at table S of the chemistry reference tables, and we have to find radon, element 86, Rn, and we go down to the density column, which is the second to last column, and we see that's a very small number, 0.009074. So remember that density. The density of radon is 0.009074 cubic centimeters. So we'll write that down. Density equals 0.009074 grams per cubic centimeter. The mass is what we're trying to find, question mark, right? It says, what is the mass of this sample? And the volume is 12,000 cubic centimeters. So we plug in we have our density. So we have 0.009074 grams per cubic centimeter is equal to the mass, we don't know, over the volume, which is 12,000 cubic centimeters. Place the density, the 0.009074 grams per cubic centimeter, over the number 1, and we cross multiply, which gives us 0.009074 grams per cubic centimeter times 12,000 cubic centimeters equals m times 1, mass times 1, but of course we're not going to write the 1. So all we have to do here is multiply. Before we do that, before we punch numbers in the calculator, we look at the units, grams per cubic centimeter, cubic centimeters. They cancel out. We're left with the unit of grams. That's great because we're trying to find mass, which should have the unit of grams. So we multiply 0.009074 times 12,000. We write down every number that comes out of our calculator. In this case, 108.888 grams is going to be equal to our mass. Our last step, significant figures, 1, 2, 3, 4. And just 1, 2 significant figures, so 2 is our least number of significant figures. We go 1, 2, put a box around the next number, in this case it's an 8. 8 is 5 and above, so we round up, that 0 becomes a 1. So our final answer, the mass is equal to 110 grams. Thank you for joining Mr. Alvarez's virtual chemistry classroom. Today we performed density calculations using Table S of the chemistry reference table. If you are trying to find mass, mass is equal to density times volume. If you're trying to find volume, volume is equal to mass divided by density. Thank you again for joining us. I hope you learned something today. Please join us again soon.